explain here is postglacial rebound. Postglacial rebound. During Ice Age, we have had big ice caps over some places on the Earth. And based on the isostasy, since the the Earth has lithosphere, and upper and also mantle here. A mantle is viscose and soft, but lithosphere is strong and solid, rigid. And this ice map press this lithosphere down. This is by this bait down into the mantle. So the lithosphere is bent. It's basically called isostasy. Now, after Ice Age, this load, I would say, is load, ice load. After Ice Age, when this ice melts and gone, the Earth is still in this form, and the land is moving upward. This phenomena is called postglacial rebound. So, in some places in the world, for example, Antarctica, Greenland, Fennoscandia, and Hudson Bay in Canada, they are experiencing this postglacial rebound. And this Earth surface or land is going upward towards the isostatic equilibrium. So, or they call it glacial isostatic adjustment. The land is coming back is on the way, actually it's not completed yet, they're on the way to come back to the. So the result of this phenomenon is called land uplift. Land uplift. So here I'm going to share one of my studies that I have done actually for you. But before that, I present a mathematical model for this land uplift. But consider that I do not go to details because you need to be very familiar with isostasy theory to get that one, to come to see understand it. Therefore, I do not present this mathematical derivation or the proof, but I give you the result instead. So this is a spherical harmonics again, and they'll tell you 2n plus 1 kn double prime m minus n. Speed of geoid changes yn. So if I have this speed of geoid from Grace, how can I say I can compute the I know that for each point yes, and then we have variation of the geoid. I can compute the variations and then fit a line in time to get this speed of the geoid changes. And if you can compute these changes globally, then you can perform a spherical harmonic analysis to get this harmonic coefficient. Kn is here is the density of, let me write K, right? Density of the crust plus the ratio, the mean MOHO depth. MOHO is the boundary between the crust and upper mantle, and density contrast between the mantle and crust. This one is density contrast. So if you have these values and insert it here, you can come to land uplift, you can see how much the land is coming up in time. So I can show you one of my studies. I share the whole screen again, then I go back to this part. I have computed map of Postglacial Rebound over Finlandia. Yes, on the left hand side you see the land uplift, the geoid changes. Geoid changes in that I have computed using GRACE data. So I have computed for 15 years point by point the geoid and fitted a line to the changes for each point. And this is a speed of geoid. As you see, the central part of the Finlandia, which is here, we have high land uplift. Later, I perform spherical harmonic analysis of these changes and insert them in the mathematical model that I showed you to get the land uplift. I compare this land uplift model with the land uplift model that the National Land Survey of Sweden has computed, and I could see a good agreement with that. So simply with GRACE data, you can come to Postglacial Rebound and measure the land uplift. But there are some issues about filtering of this model, and you see some variations that here, which could be due to actually filtering or the errors of the spherical harmonics. Then I have to use a Gaussian filter to come to that. So this way you can also compute Postglacial Rebound or land uplift only with GRACE data and with least cost. But of course there are land measurements with GPS also are very important that you need to use actually. It's not only with GRACE. So